All right, so yesterday we talked about an arithmetic sequence. Today we're going to talk about an arithmetic series. The series is the indicated sum of the terms of the arithmetic sequence. So for instance, yesterday we talked about 2, 5, 8 as sequential numbers. Today we're going to talk about, well, what is the sum of those sequential numbers? So let's take a look at an example. Here is a sequence, and I want to add them all up to find the series. Now you could go to your calculator or in your head and say 2 plus 5 is 7 plus 8 and so on and so forth, and go ahead and add them all up. But that's not really a very efficient way of adding. So let's look for a pattern. Well, I notice that the first term and the last term add to 25. The next two terms add to 25. The next two terms add to 25, and the two middle terms add to 25. So instead of adding each individual term up, it would be easier if I said, well, I have 4 pairs that add up to 25, so 4 times 5 would be 100. Let's take a look at another one here. Well, here I have 5 plus 29, which would give me 34. And so on and so forth. But now I have one left. This doesn't match up with anything. So I can say the sum is 34 times 3.5 pairs, which would be 119. So let's see if we can figure out what the formula would be so that we can use a formula to do these. Well, I'm going to take the sum. I'm going to take the first term and the last term, so A1 plus A2, and I'm going to take however many terms I have and divide that by 2. So this here is now the second formula that you will be using when we're talking about sequences and series. So in this time, if I wanted to find the sum of this using the formula, I have 7 terms, so I would say 7 over 2. The first term is 5, so 5 plus the last term, which is 29. And of course, I'll also get 119. Now, sometimes it's a little bit more difficult than that. Sometimes you're not given all the information, and you might have to use your sequence formula in order to find some of the missing pieces. So it says find the sum. So if it says find the sum, I'm always going to start with my sum equation. I'll plug in what I know. Well, I don't know how many terms there are because this ... doesn't tell me how many terms are in there, but I still know that the first term is 5 and the last term is 165. So I've written in all the information I know on my sum formula, so let me jump over to my sequence formula and see if there's any information I can find using this formula that would help me here. So the variable I really need is n. So let's plug in what we know and see if we can figure this out. Well, I know my last term is 165. I know my first term is 5. I don't know how many terms there are, so this will still be n minus 1. But I can see from the sequence that I'm going to be adding 4 every time, so I know my common difference is 4. My only variable is n, so I can go ahead and solve this equation, and I know that n is 41. So now I know there are 41 terms. I can jump back to my sum equation, put 41 into the formula, and solve it. So now I know the sum of this series, or the sum of these 41 terms, will be 3,485. Here's another example. Find the sum of the first 50 terms of the series. Well, again, they say find the sum, so I'm going to start with my sum equation. I'm going to plug in what I know. I know n this time because it tells me there are 50 terms. I know A1 is 5, but now I don't know what the 50th term is. I'm going to jump back over to my other equation and see if I can figure out what a to the 50 is. Well, I know my first term is 5. I know there are 50 terms, so I know n minus 1 is 49. And I can see from the sequence that my common difference is 4. So I can go ahead and figure out that the 50th term would have to be 201. Now that I know the 50th term, I'm going to jump back over to my sum equation, plug that in, and complete the math. So there'd be 5,150 would be the sum if I added up all 50 terms of this sequence. So sometimes there's a different notation used when you're talking about the sum of something, and it's the summation notation. You may have seen it before. It kind of looks like this weird sort of E thing. And this means starting at the first term, so the n, remember, is your number of terms. So starting at the first term, going into the last term, and this an, if you remember, is the formula for your nth term. So an example would look like this. If I said find the sum of this series, let's see if we can transform this notation into this notation here and see if we can put all the pieces in so that we can figure out what the sum is. Well, n is going to be how many terms there are. So it starts at the first term. They want me to go to the 12th term, so I know that that's going to be 12. But I have to figure out what A1 and AN are. Well, if I start at the first term, which is 1, and I'm going to plug that in for n, 4 times 1 is 4 minus 3 is 1. So I know that the first term, A1, is 1. And if I want to know what the nth term is, I'm going to take 12 and plug that in here for n. So 4 times 12 is 48, minus 3 is 45. Now I have all the information I need for this, and I know that the sum is 276. You can go the other way too, where I can give you this series, and I'm going to ask you to put it in summation notation. So remember, this is the generic form of the summation notation. N equals 1. You usually start at the first term, though you're going to see sometimes it's going to give you a different number, and you have to watch for that. But the first thing you want to do now is write a rule for a to the n. So I'm going to go back to my sequence formula. My first term is 2. N minus 1 times 3. I'm going to keep n as n because I want to write just a rule. I don't want a specific an. I want to know what the rule would be. And if I distribute all my terms and combine like terms, I know that the rule would be 3n minus 1. I can substitute this rule into my summation notation. I know there are 8 terms simply by counting 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to start at the first term. I'm going to start at the first term. I'm going to go to the 8th term, and then n at 3n minus 1 is my rule for a to the n. If you have any questions on this, please let me know.